Hello, my name is Stuti Nanwal, undertaking Communication and Critical Thinking. Today I'll be presenting on how we can use cool material as an effective strategy to mitigate urban heat island effect. So what is urban heat island effect? Well, it refers to increased temperature in urban areas compared to the surrounding rural areas. What causes it? Mainly decreased vegetation, increased use of heat absorbing materials like asphalt and concrete, and waste heat from human activities. Now, this effect increases energy consumption for cooling, air pollution, and heat related health risk. To counter the urban heat island effect, we can use cool materials that remain cooler than the ambient air temperature. These cool materials can include reflective surfaces like cool roofs and pavements, as well as advanced coating. If we can implement these cool material effectively, we can reduce the heat absorbed released in cities. Here I have outlined 3 key approaches to use cool material for mitigating urban heat. We can start by implementing cool roofs. These cool roofs are made of high solar reflectance that absorb less heat. As explained by Akbari and Kolokotsa, cool colored roofing material have been developed using special pigment that reflect near infrared radiation and keep roof surfaces cooler. Field testing has shown that cool roofs can be 4 degrees Celsius cooler than the conventional roof. Why? Because they reflect more sunlight and release less heat into the urban environment. Then, in accordance with the second approach, we can also apply advanced cool coatings to further reduce surface temperature. Mohajirani and his colleague researched and came to the conclusion that innovative coatings like thermochromic and photonic can achieve over 10 degrees Celsius cooling compared to the regular materials. These super cool coatings work through additional mechanism like fluorescent emission to maintain lower temperature. And the last strategy we are going to talk about is using porous and permeable pavements. Porous pavements lead to evaporative cooling by allowing water to permeate and be stored within the pavement structure. Research by Santa Morris and Yu found that porous asphalts can be 14 degrees cooler during the day compared to regular dense asphalt because water content helps modulate temperature spikes. Long story short, using cool materials appear to be very promising approach to encounter urban heat island effect through increased reflectivity, advanced coating, and evaporative cooling. We just have to create these materials in a way that suits our local climate and urban layout. Then cities can deploy it in an integrated mitigation strategy to promote cooler and more livable urban spaces. That's it from my end. Thank you for listening. My references can be found on the final slide.